Today's lesson objective is A.4A. Find specific function values, simplify polynomial expressions, transform and solve equations, and factor as necessary in problem situations. We're going to be looking at a few different examples of this skill. The first says, in the figure below, the perimeter of a rectangle is 20 units greater than the perimeter of each triangle. Find the length of the diagonal of the rectangle. So our question is asking us to find this piece right here. I want to find out just how long the diagonal of this rectangle is. Okay, so let's look at one of the clues they provide us. It says the perimeter of the rectangle is 20 units greater than the perimeter of each of the triangles. So let's begin this problem by finding an expression that would represent the perimeter of the rectangle and one that would represent the perimeter of the triangle. So for a rectangle, we have the formula perimeter is equal to 2L plus 2W. So my L is 3x minus 5. So our length for this rectangle is going to be 3x minus 5. So we're going to have 2 times 3x minus 5, and our width will be 2x. So we'll have 2 times 2x. Now, using a little distributive property, we can kind of simplify this a little bit. So we're going to multiply the 2 times each of these terms. So 2 times 3x and 2 times negative 5. And then in the back, we have 2 times 2x. Here we can use the associative property to move the grouping symbols to the front around the coefficients there. All right, so let's simplify this a little bit. 2 times 3 is going to give us 6x. And then negative 2 times 5 is negative 10. And then 2 times 2 will give us 4. All right, and so now we can use our commutative property to rearrange the order of these so that we can put the x's side by side, and use our associative property to help us group these like terms together. So it helps us to see what we're actually adding together. So 6x plus 4x is 10x, and then we have the minus 10. Now we're going to do the perimeter of the triangle, which means you're going to simply add the 3 sides of the triangle together. So side 1 plus side 2 plus side 3. So we'll make side 1 3x minus 5, side 2 can be 2x, and side 3 will just be 4x minus 10. Once again, we need to simplify this expression, so we're going to start by removing the parentheses. Here, the parentheses really don't have anything outside of them that needs to be done to them, so we can just simply take them off. Okay, just like before, we're going to use a combination of the commutative property to rearrange the like terms to be next to each other, as well as the associative property to help group the like things together. So we're going to group all the x terms together, and we'll group all the constants together. So if we add the x terms, 3x plus 2x plus 4x, we end up with 9x. And add negative 5 and negative 10, we end up with negative 15. Okay, so next, let's talk about that relationship that they told us in the problem. It said the perimeter of the rectangle is 20 units greater than that of the triangle. So the rectangle would equal the triangle if we would just add 20 units to the triangle part. Then they would be equal in size. All right, so using that relationship and what we've discovered earlier about our perimeter expressions, we can say that 10x minus 10, which is the rectangle, should equal 9x minus 15, which is the triangle, plus 20 units. So now we're just going to combine these constants on the end to get negative 15 plus 20 makes 5. And now it's just a matter of isolating or solving for the variable. So let's move the variable to one side by subtracting 9x on both sides. So this gets rid of the x on this side, and we're left with just 1x on this side. So x minus 10 equals 5. Now to finish isolating the x, we're going to add the 10 to both sides. And so we get x equals 15. Now, word of caution, a lot of times we think this is where we stop and we don't have to do anything else in these problems. However, if you remember from the question, what we highlighted here was the diagonal. We want to find the length of the diagonal, not the value of x. So we're going to have to plug in 15 and for the x and 4x minus 10. And solve for the value of the diagonal. So 4 times 15 is 60, take away 10, leaves us 50. All right, and so that's one example of a problem that uses A.4A. Here's the second example. And this one says a manufacturer builds cubicle containers. The equation that models C, the cost of building a container, is C equals 3.6 times S plus 3.20, in which S represents the length of each side of a cubicle container in feet. So basically S would be, since it's a cube, they're all the same. So it's the length of one side of the box. So it says find the length of each side of a cubicle container that costs $35.60 to manufacture. So we're going to substitute that cost, that $35.60. I do apologize, the writing's a little rough today. I'm trying to do this with a wireless mouse. So we're going to substitute $35.60 in for C in the equation that models the cost of building a container. Solving the equation for S, which is the length of the side. Okay, so here's our equation. We replace C with $35.60. We're going to isolate the variable S. So we start by removing the 320 that's being added. And what do we do to one side? Of course, do to both sides. That's our equality property. So here we're using the subtraction property. Okay, and so on this side, they just equal 0, so that goes away. And on this side, you subtract that, and you get $32.40. Okay, so S is still not quite isolated. We still have this times 3.6. So again, using the inverse operation, we're going to divide. So we're going to divide both sides here by 3.6 using the division property. And so over here, 3.6 divided by 3.6 just equals 1, so you just have 1s. And over here, you would do the division, and you'd find that this equals 9. Okay, and so the side length is 9 feet for this container. For that, if it has a cost of $35.60. All right, let's keep moving. All right, here's another example that would involve using A.4A. It says the composite figure shown below is composed of a rectangle and an isosceles triangle. Composite figure, remember, just means a combination of geometric shapes. So this one is composed of a rectangle and an isosceles triangle. Now recall from your geometry vocabulary that isosceles triangle means that at least two sides are equal. So in this case, if we know that this one's x, they're trying to tell us that this one over here is also x. So let's go ahead and just label that. And since this other shape is a rectangle, we know that opposite sides have to be equal as well on a rectangle. So since the top there is x plus 4, we'll go ahead and label this as x plus 4. And since this is x plus 6, let's go ahead and just label this one as x plus 6. Okay. Alright, so we got all the shape labeled. Now let's see what we need to do with it. So this first part says, what is the area of the shaded region in simplified form? Okay, we're actually going to show our work here on the screen. So again, we know that for a rectangle, area is equal to length times width. So for my rectangle, my length and width are x plus 4 and x plus 6. It really doesn't matter which one you let be your L and which one you let be your W, because since we're multiplying, it doesn't change the outcome. So we get x plus 4 times x plus 6. Alright, so in order to simplify that expression, we're going to use distributive property. Some of you may have learned this as using FOIL. We're going to start by multiplying the first two terms together, x times x, to get x squared. And then we're going to do the outside, x times 6, which is 6x. And then we're going to do the inside. So we got x times 4 is 4x. And then finally we're going to do the last. So 4 times 6, which is 24. Alright, so then after that, it's just a matter of combining like terms together. So here you got 6x plus 4x. So the area of my rectangle is going to be x squared plus 10x plus 24. Now we can't stop there because that's just the rectangle portion only. So we need to find the triangle as well. So over on this side, let's find the area of that triangle. So remember, for our formula for area of a triangle, we're going to use base times height. Divide that by 2. Okay, so on my triangle, my base is this x plus 6, because the height is right here, it's 2x minus 14. So we're going to do x plus 6 times 2x minus 14, and then we're going to divide that by 2. Okay? And there's a couple of ways you might approach this problem. Some of you guys may want to divide one of those lengths, either the base or the height, by the 2 first before you multiply. Can't divide them both by 2. It's going to be one or the other. Or some of y'all may want to just multiply first, and then when you're done, divide everything by 2. Whichever way you find simpler. I could easily see dividing the height, 2x minus 14, by 2 first, and then multiplying, and it come out, make the math a little simpler. But just in case you don't see that, we're just going to go ahead and multiply the tops together, and then we'll divide by 2 at the end. So again, we're going to use FOIL here. So we're going to do x times 2x is 2x squared. X times negative 14 is negative 14x. And, and then 6 times 2x is 12x. And finally, 6 times negative 14 is negative 64. Nope, it's not either. It's negative 84. Alright, and so I would probably combine my like terms next. On the top, we got negative 14x and a 12x. So that's going to be 2x squared plus, or minus 2x rather, minus 84. And so then now we're ready to divide everything by 2. So 2 divided by 2 is just 1, so that's just x squared. Negative 2 divided by 2 is negative 1. So it's just negative 1x, or just negative x if you like. And then 2 goes to negative 4 42 times, so that's going to be negative 42. Alright, so now we found something that represents the area of our triangle. Our final step is to combine that with our rectangle here. So I'm going to do that down here in this space. So we got x squared plus 10x plus 24. And we're supposed to be combining that with x squared minus x minus 42. Alright, so now it's just a matter of adding those together. So 1x squared plus another x squared just makes 2x squares. 10x take away 1x, leaves us with 9x. And then here we got 24 minus 42, which is what, negative 18? Okay. Alright, so that expression, 2x squared plus 9x minus 18, would represent my area of my composite figure. Okay. This last part here asks us to find the perimeter of the figure in simplified form. Find the perimeter of a composite figure means you're just adding the outsides together. So here we would do x plus 4, just pick a corner and go all the way around. X plus 4 plus x plus x plus x plus 4 plus x plus 6. So I would combine my x's first. There's 1x, 2x, 3x, 4x, 5x. So you have a total of 5 x's. And then add my constants. There's 4, 0, 0, 4 is 8, and 6 more is 14. So the perimeter would be 5x plus 14. That's usually pretty simple to do. Okay, this concludes part 1 of this. We're going to go ahead and stop the recording and start part 2.